I will start it in 1 second here when the recording thing says it's ready for me. Hang on. Hi, this is Ryan Holger with HVAC Solutions and Temperature Equipment Corporation. Thank you for joining us today. I believe you guys can all hear me fine based on the notes you had sent in. Today's topic, and for those of you that don't know, we do a webinar every Monday at lunchtime. So today's topic is high efficiency boilers. I'm going to go through that topic and talk to you about some of the things that relate to it in terms of energy rebates and things like that, but also talk to you about some specific boilers as well. So with that being said, here we go. A lot of you probably have seen this type of data before, but this is the environmental impact we have on buildings, or have on the earth because of buildings, I should say. This is both commercial and residential, and about 40% of our energy consumption for the country is being used to heat and cool buildings and lighting. And this is how it breaks down specifically for both commercial and residential. So 40% of the usage is for buildings, and of that 40%, about 38% of it is for space heating and 8% for water heating. And those are things that we might be able to affect with a boiler. For residential situations, it's actually much more. Space heating is about 40%, and water heating is about 20% of the energy. So more than half the energy in your home can be affected by a boiler. Obviously, some homes have forced air, and a boiler might not be useful there, obviously. I'll show you commercial in a minute, but let's go through a couple of residential things, then we'll talk about commercial, then we'll talk about boilers specifically. So I'm assuming everybody knows that right now we still have residential federal tax credits available. Those do expire at the end of this year, December 31st, 2010. It is very highly unlikely that they will be extended in any fashion. If there is any credits or tax credits available next year, it'll probably be for residential home auditing and not for replacement of equipment specifically. So you got 6 or 7 weeks to go ahead and finish things up with customers that may be pending. What it is you get 30% tax credit, and that's not a deduction, it's a tax credit right off the bottom of up to $1,500. And it has to be for your principal home, and the boiler has to be 90% AFUE, so 90% efficient. In addition to tax credits, there's also many utility rebates available both residentially and commercially. These ones are the residential ones, and you can see that same 90% boiler that gets you a federal tax credit also gets you $350 from NICOR, or if you bump it up to a 95% boiler, you can get $400 from NICOR. Down at the bottom there is the website where you can find more information. It's NICORgasrebates.com. These are going through May 31st, I believe, and they are very likely to be extended in future years. So tax credits end in December. The gas utility rebates extend all the way through the heating season and end in May as it stands today. And then Peoples and North Shore, which is also in the Chicago area here, they're owned by the same company, so they have a program that's together. It's chicagolandrebates.com, and it's for Peoples, it's the same as NICOR. A 90% boiler gets you $350. A 95% boiler gets you $400. And then on the North Shore side, there's only one tier, 90%, and it's $350. For those of you over on the other side of the border in Indiana, NIPSCO does have residential rebates, and it's quite attractive. It's $500 for a 90% boiler. Additionally, there's also a state tax credit for residential HVAC upgrades, and that is $100, and that ends at the end of this year also, just like the federal tax credits. And then lastly, if you're over there in Michigan, some of you on this call are, in that case, there's a $200 rebate residentially for a gas boiler. It only has to be 87% AFUE, although there's not a lot of 87% boilers out there, so chances are you'll end up putting a 90% in anyway. Plus, right now you'll get the federal tax money, so you should put a 90% in. And there's also some state tax credits available as well. So the websites for all those groups were on the bottom of each of those slides. So if you didn't get a chance to write them down, you can always watch the recorded version and jot them down as well, or let me know and I'll send them to you. On the commercial side of the equation, this is kind of what things look like. We spend about 14.7 quads of energy annually in our country, and this data is from 8 or 9 years ago, but it's the most current study out there. 30% of that's for HVAC and 8% is water heating. If you look at it a little bit further, 1.4 quads go to cooling, which is not today's discussion. 1.7 quads go to heating, and of those 1.7 quads, 20-some% of it is for boilers specifically. So there's a lot of quads of energy that can have potential to be saved here. And then not to forget about it, but there's also the parasitic energy consumption, and in terms of a boiler system, it's the pumping systems. In terms of an airside system, it's all the supply and return fans, which consume most of the energy. But pumps, heating pumps do take up some of that, 5% of another 1.5 quads. So what does all that mean? All that means is there's a lot of potential out there. Existing buildings, there's about 5 million commercial and institutional buildings in the U.S. that correlate to 70 billion square feet of space. And there's a statistic out there from one of the gentlemen at ASHRAE. I forget which ASHRAE president said it, but it comes off of some of the study data. And it was 80-some% of the buildings that are going to be standing in the year 2030 are already standing right now today. So for those of you that do both residential and commercial work, just make sure you don't forget about those existing buildings. Make sure, whether it's homes or commercial buildings, a lot of these buildings are already out there. So don't just focus on new construction, big projects. All the little tiny renovation things are where most of the activity is going to be the next 20 years. So a lot of opportunity. Commercially speaking, there is no federal tax credit, although there is a federal tax deduction. It works quite differently than the residential programs. In these cases, in almost every scenario, you're going to have to do an energy model to figure out what your potential is going to be. It's up to $1.80 per square foot if you exceed the ASHRAE standard 90.1 2001 by 50% or more. So basically, you have to model your building as if you were building it to the 2001 standard, and then go ahead and model it again the way that you're going to really build it, or the way that you're really going to renovate it in this case, and then see for 50% better on the energy consumption. If you're building a building to the current ASHRAE standard, to the current code basically, you're already about 40% better. So if you're building it to the new 2010 standard that came out a few weeks ago, you're already 40% better than 2001. So, getting up to code gets you almost all the way there to getting this tax credit. If you don't want to make, or you can't afford to make improvements to envelope lighting and heating and cooling, you can pick just one of those three and get 60 cents per square foot. Or you can implement all three of them and get up to $1.80 per square foot. You're going to have to use an approved energy modeling software. The Carrier HAP program, the hourly analysis program, is approved for that use, as it is for code applications and other stuff. And the big difference here, other than being a deduction versus a credit, is that the commercial ones do not expire at the end of this year. I get a lot of questions on that. People get confused. The commercial tax deductions extend through December 31st, 2013. So we have 3 more years of commercial tax credits being available. Commercial tax deductions being available. The residential stuff ends this year. All right. If you guys haven't noticed, on the webinar tool, down in the bottom right-hand corner, there's a little question chat box area where you can type stuff in. So if you have a question, go ahead and type it in, and I'll do my best to answer it as we go here. So in terms of rebates, there's NIPSCO has commercial rebates as well, and for boilers, it's at 85% thermal efficiency. You get $2 for every 1,000 BTUs. And if you put a 90% boiler in, it's $4 for every 1,000 BTUs. So if you put a 1,000,000 BTU boiler in, you would get a $4,000 rebate from NIPSCO. That's how that would work. Additionally, there's an item on here for boiler reset control as a retrofit, $250. However, we have been approved in the past to be able to do that on new construction, or I should say new construction, on boiler changeouts. So you can either add reset controls to an existing boiler that does not have any, or if you put in a new boiler and you didn't previously have any outside air reset and you add it in with the new boiler, you can get another $250. So that 1,000,000 BTU boiler that's getting you $4,000 rebate now gets you $4,250 rebate, right? If you were doing the 1,000,000 BTUs with 2 boilers, each 500,000, you would get $2,250 for each one, or a total of $4,500. So the boiler reset control is $250 per boiler, okay? There's also custom incentives available. For most of the boiler stuff, we're going to fall in this prescriptive scenario, but if you came up with something that's also going to help shed the gas load on the building, like energy recovery ventilators or demand control ventilation, you'd be able to take credit for those as well, even though they're not listed specifically. For Peoples in North Shore, they have a combined program, because once again, they're owned by the same company. ChicagolandRebates.com is the website there, just like it is for the res stuff. Commercially speaking, for a boiler that's 85% efficient, it's $2 for every 1,000 BTUs, just like Nicor. And then for the 90%, it's $4 for every 1,000 BTUs, just like Nicor. And then you get the same $250 per boiler if you add outside air reset controls. So for commercial, the boiler rebates are exactly the same for Nicor, Peoples, and North Shore. All three gas utilities in the Chicago area are lined up. There's also a custom program available for these if you want to do ERVs or something like that in conjunction with your boilers. In Indiana, there is a state tax credit for commercial HVAC upgrades. It expires at the end of this year. It's $100. It's not really anything to get excited about, obviously. In Michigan, the Michigan gas utilities have a program. It's called Efficiency United, and that's the website, efficiencyunited.com. The boilers have to be 88% efficient, so that fits in line with some of these other programs. And you'll see that you get $1 for every 1,000 BTUs. So in this case, a 1,000,000 BTU boiler would get you $1,000 rebate. And then they also have the boiler water reset controls for outside air reset, which is $300 per boiler. You'll also notice on all of these programs there was additional stuff on here related to boilers. And shame on me for not mentioning it. I'm so equipment focused I wasn't looking at the labor side of it. But there's boiler tune-ups available as well. So Michigan was a $250 rebate to do a boiler tune-up. And for Nicor, it was $350 to do a boiler tune-up. So there is money to do that kind of stuff as well, in addition to equipment replacements for both Nicor and Michigan gas utilities. All right. So let me look and see if we have any questions, and then I'm going to talk to you about a couple boilers, and then I'm going to talk to you about some more free money opportunities, if you will. Okay. Let's see if we have any questions here. Let's see. I don't have a question, but I do have a comment from one of the folks that helps administer the Nicor, Peoples, and North Shore rebates. It's saying that steam traps are repair or replace now. So previously, I believe, we'll see what it was here a second ago. Look at Nicor, it was replace steam traps for $50 a piece. Now what John is saying here from Nicor is that you can repair them or replace them. So you have some choices there. If you have any other questions, please type them in the bottom there under the question chat box, and I'll be sure to answer them as we go or at the end. Let me jump back to where we were here. All right, so I'm going to talk to you about a few specific boilers, and then I'll talk to you about some more financial incentive stuff available. Up here on the screen, we have HTP. HTP stands for Heat Transfer Products. Many of you probably know it as Munchkin. They were one of the very first condensing boilers to make their way to the United States 10 or 12 years ago. So they've been around for quite a while. And being first is pretty good because you get to do everything first and get your name out there. But it can also be bad because sometimes your equipment is special and it has to be installed differently than traditional stuff, in this case cast iron, and people don't understand the rules. But nowadays I think most folks are pretty well aware of the rules of installing a high-efficiency condensing boiler. If not, we offer a lot of training classes, hands-on in our lab, to teach people how to do it. So let me know and I'll get you involved with those if you need it. Let me walk through a couple of these things for you. 1999 is when that Munchkin boiler came to the United States, so that's 11 years ago. And things have been evolving since then. I'll talk about a few of the lines that HTP has, and then we'll talk about a few other brands as well. One of the things that they have is called the MC Series, or for those of you that have been around for a while, it used to be called the Munchkin Contender, but now it's MC Series. It's a wall-hung boiler. It's very small. It has a very durable plastic outer shell on it. It's 93% AFUE, so it does qualify for all those rebates for the residentially speaking for tax credits and utility rebates. The small size is 50,000 MBH. The larger size is 120,000 MBH. They are condensing and modulating boilers. So if you're not familiar with those terms, condensing, just like with a condensing furnace, it means we're going to allow some of the flue gases to actually condense and run back into either a secondary heat exchanger or to the backside of the original heat exchanger and reclaim some of that energy, right? So because these flue gases are condensing, we can't do that on a traditional, cast iron boiler. It'd be too corrosive. So we have to use stainless steel or aluminum or titanium or some other metal like that. In this case, these are stainless steel heat exchangers in these boilers here. So they're condensing, so we're grabbing some of that energy out of the flue gas, which is how we get up above 90%. Typically, when you're below 90%, you're probably not talking about a condensing boiler. When you're above 90%, you typically are a condensing boiler. I'm sure there's exceptions to that, but that seems to be how most manufacturers are set up. And it's modulating, which means that it's not, if I have a 120,000 MBH boiler, it doesn't mean I have on, off, 0 or 120. It means I can modulate between 0 and 120. Or maybe not 0, but say 50 and 120 or something like that. And I can hit various points in between there. So I can more appropriately match my boiler capacity to my actual load at a given moment. The cool thing about this boiler, as well as most of the boilers I'm going to show you today, they vent with Schedule 40 PVC, so you do not need stainless steel venting. So Schedule 40 PVC is a regular off-the-shelf item. It's not very expensive. Obviously, stainless steel is, so if you can avoid that on all the venting, it's a lot better. So these guys vent with regular Schedule 40 PVC. The heat exchanger on these guys is a 12-year warranty on the heat exchanger. There's 3 years on the blower and 1 year on all the other parts. Just gives you an idea what some of these things look like. And just for example purposes, the last one, 120,000 MBH, weighs 84 pounds. So these are very light boilers. They don't stick out very far. They can fit in pretty tight spaces, and all the piping and everything comes off the bottom. All the venting's on the top, nothing on the sides. So you can slide them into a pretty skinny spot. All right, so here's a typical drawing of a condensing boiler, and I'm talking specifically about HTP boilers now, and most stainless steel heat exchanger boilers from most manufacturers. And then there might be some exceptions to that, and I'll point those out as we go. But for most part, this is how you're going to be piping these things. So I'm hoping that you guys can see my mouse moving around here on the screen. On the right-hand side here is a condensing boiler, stainless steel heat exchanger. And then coming off the bottom of him is my supply and return piping. And you can see as that loops around, there is a pump labeled as P1. And then up to the top here where the closely spaced T's are, and loops back around. So between the boiler through that pump is one loop right there. All right. I have a second loop in this case, right? So I have my primary loop at the boiler, and I have a second loop out in the space that's circulating throughout my house or throughout my building with all my various zones on it. What happens with these condensing boilers, with these stainless steel heat exchangers, they have fairly small passageways to shove the water through. So it's good because we get more surface area, we have less water to hold in the boiler. The downside of it, though, is it takes more energy to pump through that. So we typically can't take an old cast iron boiler out that just had one large primary loop for the whole building and drop a condensing boiler in its place without changing some piping. So I got to change it to primary, secondary piping, and that's a whole other topic in itself. But you get the basic idea here. Instead of having one big loop going throughout the building, I have two loops. One in the boiler room that's just circulating water through the boiler and moving heat from the boiler to the secondary loop and then back. And then I have a second loop that goes out and hits all the zones. So with these condensing boilers, these stainless steel heat exchangers from almost every manufacturer, you have to do primary, secondary piping. All right, so keep that in mind. The other cool thing we're showing on this drawing here, over on the left-hand side, we have an indirect storage tank on there. That basically is a very nice water heater tank, if you will. Instead of having a burner in the bottom of it, it has a hydronic coil, and I'm able to take water from my boiler, send it through that coil to heat up my domestic water. The water is not the same. They don't touch. I have my domestic water separate from my boiler loop water, but I run a coil with that boiler loop water into that tank just to warm up that water. So I can get rid of that fairly inefficient gas burner that's in a water heater, and now in this example, I'm using a 93% boiler to heat my domestic water as well. And you can see I have two pumps in this case, P1 and P2. Both of them are controlled by this boiler. What this boiler can do is look at a sensor that we install in that domestic water tank, and say we set it up for, 106 degree water, and we see the water temp drop to, say, 140. We say, okay, we need to heat up the domestic water. I'm going to shut off pump 1 and stop heating the house or the building, turn on pump 2 and heat up the domestic water, and then it'll take, 10 minutes, for example. And then when that's satisfied, I'll turn pump 2 back off and go back over to pump number 1, heat the building again. If I have heating systems in the building that are radiant floor heating or other large mass heating, like cast iron radiators and things like that, if I stop heating those for 10 minutes and pull over and do the domestic water, no one's going to even notice. It's not going to affect the room temperature at all. So you can do that. You can use one boiler to do two jobs. So that Munchkin Contender went up to 120,000 BTUs. He has a big brother called the Elite boiler. For those of you who are familiar with HTP, this guy takes the place of the Munchkin boiler. He can be wall hung or floor mounted. Depending on the size you're looking at, he's between 94% and 98% AFUE. I think the 98% is the 220 and 299 MBH sizes, although the whole thing goes up to 399 if you want. There's 6 different sizes. It's condensing and modulating, right? So condensing means we're going to allow the fluid gases to condense on the back end of that heat exchanger so we can reclaim that energy instead of sending it out the exhaust pipe. That's how we're getting these high AFUE ratings. And it's also going to be modulating. In this case, the modulation is a 6-to-1 turn down. So if you're not familiar with the term turn down, you can think of it a little differently. If I have a 10-to-1 turn down boiler, that means I can modulate from 100% all the way down to 10%. If I have a 5-to-1 turn down, I can modulate from 100% down to 1/5 of that, which is 20%. And in this case, I have a 6-to-1 turn down, so I can go from 100% down to 16 or 17%, whatever the math works out to. So the bigger the turn down, the better it is for me to be able to handle smaller loads. Or if I have smaller zones and only one zone's calling, I'm better capable of handling that. He has the same stainless steel heat exchanger that the Munchkin Contender has. One big difference are vent runs. The old Munchkins only went up to 85 feet. The Elite can go up to 200 feet on the vent run. That's 200 equivalent feet. So that's pretty long. That certainly takes care of any residential situation and most light commercial projects. On the commercial projects, this guy has built-in controls that not only do outside air reset, so the other one I showed you too, the Munchkin Contender, he does outside air reset, and every condensing boiler I'm going to show you today does outside air reset, because there's no point in buying a condensing boiler and not allowing it to condense. And putting out 180 degree water is not going to allow you to condense. You got to get that water temperature down below, say, 130 for you to get into a condensing mode. So what we need to do on mild days when it's 40, 50 degrees outside, we need to keep that water temperature set point low, say 110 to 130, in order to be able to get that into condensing mode. But then if it's really cold out, like -10, that design day that almost never happens, on that day, go ahead and let it ramp up higher if we need to, up to 180 or whatever we need. So outside air reset controls not only get you a rebate from the gas utilities, it also saves you quite a bit of money in the operation of that system. So that's standard with these boilers. They have outside air reset controls built in. They ship with an outside air reset sensor on them. They also have built-in standard controls to be able to sequence up to 8 boilers. So if I wanted to put in, say, 2 399,000 BTU sizes on a light commercial building and get myself a total of 800,000 BTUs, I can do that with 2 of these guys. Run a cable between them and add no additional control hardware. Just tell one guy he's the master, tell one guy he's the subordinate, and let them coordinate with each other. The master will tell the other one when to stage on and when to stage down. They may both need to fire together on a really cold day, or maybe just one of them needs to fire, and he'll also lead lag rotate them so it gets equal run hours on each boiler throughout the year. And these guys have a low water cutout standard, which helps you out on commercial jobs as well. Same warranty, 12-year heat exchanger, 3-year blower, 1-year parts. This just shows you some of the dimensional data and info for these guys. The 80,000 BTU is only 108 pounds. The 220 goes up to 164 pounds. And then when you get to the really big ones, the 399 size is 256 pounds. So he's probably not going to be a wall mount. He's probably going to be on the floor somewhere. All right, if you need bigger than 399,000 BTUs, there's yet an even bigger brother to that other boiler. It's called the ModCon, and ModCon stands for modulating condensing, but the name's a ModCon. It's 94% efficient for all 3 sizes. The sizes available are 300, 500, and 850,000 MBH input. It's a 5-to-1 turn down, so we can modulate from 100% down to 20% on a single boiler, right? And if I have multiple boilers, say I had 2 boilers, then I'd be able to modulate from 100% down to 10%. If I had 4 boilers, I can go from 100% down to 5%, right? I can kind of keep scaling that back. Some of the really cool things about these boilers, they have the same controls I just talked to you about a minute ago. So they have outside air reset built in. They have a built-in sequencer for up to 8 boilers. So one guy becomes the master, the other 3, 4, 5, 7 of them or whatever become the subordinates, and they're listening to instructions from the master. And you can also stack them too high. So they have the ability to take 2 boilers of the same size and stack them on top of each other with no additional framing or support required. They go right on top of one another. The warranty is 10 years on the heat exchanger, 3-year blower, 1-year parts. That's just some dimensional info on those guys. All of them have all 3 sizes, 300, 500, and 850. All 3 sizes are the exact same height and the exact same width, and the only thing that changes is the length of the boiler. Physically, how long does it get or how deep does it get, if you want to think of it that way. They all look the same regardless of the size. Along with those boilers, if you're going to do domestic water, you need to have an indirect water heater, which, like I said before, is basically a tank, a water heater tank, but instead of a gas burner on the bottom, it has a hot water coil. And then obviously there's no venting for flue gases because the venting side happens at the boiler, not at the tank. You can get these in stainless steel or glass lined. At our office, we stock them in stainless steel because they have a lifetime warranty that way. If you get a glass one, it has a 7-year warranty, just kind of like a regular water heater might. And you can get them in single or double wall, depending on what the code requirements are of the area that you're in. Different municipalities have different rules on that. All right, switching gears a little bit here, I'm going to look and see if we have any other questions, and I'll talk to you about a couple other boiler lines and then go into some more financial stuff here. Let's see. All right, so I got a question here. What sort of efficiency would you be looking at during the summer when the boiler is only heating for the indirect hot water tank? That's a pretty good question. The efficiency of the boiler itself doesn't change based on the season, right? Well, I guess it does slightly because the outside air, combustion air that you're bringing in might have an effect on it. So in the wintertime, like I said, some of those boilers, like for example, the last one was 94% efficient for that ModCon, right? Go back there. He's 94% efficient in the wintertime. In the summertime, he might be a slight hair or two better than that because he's not taking in 0-degree combustion air. He's taking in whatever 80-degree combustion air or 90-degree combustion air. But it's going to be really small. Instead of 94%, it'll be like 94.2 or something like that. There's no efficiency loss for running it in the summer. It's actually a slight efficiency gain. But even if there was a loss, or even if it was equal, it's still significantly more efficient than a water heater. Gas burning appliances like furnaces, boilers, and water heaters really don't change efficiency based on the season. But things like heat pumps and air conditioners do because they are rejecting or claiming heat from the outdoors. So that makes a big difference. A boiler, he's doing his own thing. It's a combustion efficiency thing, and then he spits his exhaust out, and he spits his exhaust outside, and he doesn't really care. He's not grabbing any energy from outside. If I had a heat pump, he's grabbing energy from outside, so the outside air temperature matters. Gas appliances, it doesn't really matter. Let me see if there's any other questions on here. Okay. If you have any questions, please type them in the chat question box down in the bottom right-hand corner of your screen, and I'll do my best to answer them as we go. All right. So another boiler line that I'll show you that we've been working with here for a year or so. And by the way, for the HTP stuff, we've been handling that for about 8 years, and Bill Bailey in our office was handling it for several years before that. So we've got a lot of experience with those. IBC is a little bit newer to us. We've been handling that for about a year and a half. There are some cool things that it does. It does a lot of the same stuff. It's high efficiency. It's condensing. It's modulating. It has a titaniumized stainless steel heat exchanger, which means that we can get some longer warranties with it. The residential ones have a 20-year limited warranty on them. But there's 2 reasons why we like to use this boiler a lot that he does different than some of the other boilers that we have available to us. One of those is on the 150,000 BTU size. He has a 10-to-1 turn down, which means I can go from 150,000 BTUs down to 15,000 BTUs, or from 100% to 10% if you want to think of it that way. So that allows me to accommodate much smaller zones than I might on another project. So if I want to, if I want to micro zone the system and have very small zones like a bathroom on its own zone and things like that, this boiler will do a very good job of that. The other thing that he does that's pretty cool is he can handle up to 3 different temperature loads. So I showed you an example before of 2 temperature loads. One of them was for space heating, where pump 1 was supplying to the space, and the other one was for the domestic hot water tank, where pump 2 was supplying. And I was able to switch between those 2 loads. The boiler could send water one way, or it could send water the other way, and change the temperature to match what that load needed. This boiler can do that with 3 different temperature load profiles. So I could send water to my radiant floor slab, or I could stop doing that and send water to my domestic tank, or I can stop doing that and send it over to an air handler or some thin tube baseboard or whatever. I can switch between those and send 110 degrees to the floor slab, 160 to the domestic tank, and then 180 over to the thin tube baseboard. So those are the real two things that this guy does really strong, which is 10 to 1 turn down on that particular size, and the ability to handle up to 3 different unique temperature loads. He's also kind of cool because even though the AFUE formulas don't reflect this properly, he has very good efficiency, and you can measure that with your combustion analysis meter or temperature gauge. The exhaust temperature coming out of that stack of that boiler is never more than 5 degrees warmer than the return water coming back to that heat exchanger. A normal boiler might be 30 or 40 degrees warmer. This guy at most is going to be 5 degrees. So if you're not sending energy out the exhaust, that basically means by definition you're keeping it in the building. So hopefully the AFU formulas catch up to that technology and reflect it a little better soon here. And then there is a commercial version of that boiler, 399,000 BTUs, and it's a 95.7 thermal efficiency. Similar type controls, outside air reset built in, multiple boiler staging. I think you can stage up to like 24 boilers off of his standard controls. And there is an option for a backnet output if you're trying to tie this into a building automation system and get some more data off of him. And then the last line I want to show you here is Utica. Utica is a boiler manufacturer we've been dealing with for several years here, and the highest efficiency boiler that they have on their line today, and that's going to change in a couple months here, but right now it's the Utica UB95, which is 95% AFUE. It's modulating condensing just like the other boilers. He has an aluminum heat exchanger instead of stainless steel. Built-in outside air reset controls just like the other boilers. 15-year warranty on the heat exchanger, 1 year on the parts. There's a free 5-year parts and labor warranty that's available with it. So you just have to turn in a little mailer card, and you can get that free 5-year parts and labor warranty. The really cool thing about this boiler, and one of the reasons we like using it, well, one, it's cost effective. It's less expensive than some other boilers out there. But two, it's really good for direct replacement on an existing system. By that I mean, if you remember I talked about on those stainless steel heat exchanger boilers from HTP and from HTP's competitors, you have to do primary and secondary piping. You got to have one loop for the boiler and a second loop out there in the field taking care of the building or the house. This Utica UB95 is designed to directly replace the cast iron boiler without having to change the piping arrangement. So if I don't have primary secondary today, I take out an old cast iron boiler, I put this guy in, I don't have to change the piping, right? There's still benefits to doing primary and secondary piping, but the boiler's not going to make me do that, right? The application might, but the boiler's not going to. I still have to change the venting, because this guy's going to need to be vented with Schedule 40 PVC, so I'm not going to vent it with regular sheet metal. At least I don't have to change all the piping around. So you can go in, take out a boiler, put this guy in his place with minimal labor impact on the building. So that's why we like this guy a lot for those change-out type situations. He has some little brothers, UB90, which is 90% AFUE, so that still qualifies for all of the federal tax credits and for the utility rebates. So the UB90s come in 7 sizes from 50,000 MBH up to 200,000 MBH. These are extremely cost-effective boilers. It's probably the most cost-effective boiler that still qualifies for all the applicable rebates that you can get your hands on. So it's really good in that regard. It is a condensing boiler, so that's how we're getting the 90% efficiency. However, it is not a modulating boiler, so it is on-off control. So if I had a 100,000 BTU boiler, it'd either be running at 0 BTUs or at 100,000. It would not modulate in between like all the other boilers I showed you previously. Okay? For those of you on the call that are familiar with Carrier and Bryant products, and I know several of you are, some of you guys are Carrier or Bryant dealers, they have a boiler called the BW9, which for all intents and purposes is the exact same as this boiler. It's made in the same plant and everything, so it's got the same stuff, 90% AFUE, condensing, qualifies for all the tax rebates, etc. And I'm not going to talk about cast iron boilers today because cast iron boilers really don't hit that goal of high efficiency boilers that we want to talk about on this webinar. So just want to let you know that we do have Utica cast iron boilers if you need that. Obviously, we're going to do our best to talk you and your customer into putting something in that's high efficient. But if it's just not feasible because you can't afford the venting or the piping changes or whatever the case may be, just know that we could still help you out with cast iron stuff, all the way from 50,000 BTUs up to 3 million BTUs. So that stuff's out there too. And then coming down the pipe very shortly, and I probably shouldn't even show you this to you because then you guys will probably call me and ask me for it, and I'll have to tell you it's not out yet. But in January, I'm hoping it would have been November, but unfortunately it's probably going to be January, is the ECR 97 GB boiler. ECR is the parent company of Utica. So this is their new boiler that's coming out. The first two sizes are going to be 75,000 and 100,000 MBH, with the larger sizes to follow in the second quarter. They're 97% AFUE, so that's pretty cool. They can be floor or wall mounted. I've seen this boiler a couple times now physically. It's pretty cool. Some of the cool features, obviously it's condensing, obviously it's modulating. It's got a 5-to-1 turn down, which means we can modulate from 100% down to 20%. It does have a stainless steel heat exchanger, which is unlike the other high efficiency Utica boilers that have aluminum. This one is stainless steel. However, we don't have to do the primary secondary piping. And the reason we don't have to do that is because, I don't know if you can even see in this picture up here, but there's a small Grundfos pump right there. Inside this boiler, there's already a pump and a small little primary loop. So physically inside the cabinet, there's already a primary loop. So when you stick this in the field and put it on your secondary loop, when you put a pump on it, it's already set up to do that. So it is primary secondary piping because those small stainless steel heat exchangers need that. However, from the application perspective, the installation, if you will, you don't have to change anything. The building is just one big loop, one big secondary loop, and the primary loop is already factory installed in the boiler for you. So that's a big advantage. Has the outside air reset controls just like you'd expect. 15 years on the heat exchanger, 1 year on the parts. And it's 97% efficient, which is going to be pretty cool, cost effective. And then at our office here, we handle pretty much every possible accessory that you might need to go with a boiler system. As you can see on the screen here, we have Rayhow PEX tubing that we use for radiant heating in floors or in ceilings, and snow melt systems, things like that. And all the accessories and manifolds, we have all that kind of stuff. Pumping systems, we have several different lines of pumps here. This is showing you the Grundfos and Payco pumps. We also have Bell & Gossett pumps that we use as well. But we use Grundfos a lot on boiler systems residentially and like commercial. For the larger commercial stuff, we typically use Payco, P-A-C-O, and that is a company owned by Grundfos. They bought them a couple years ago, and that's where we get all of our bigger pumps from. They go up to 20,000 GPM, so quite large. And then if need be, we can build you custom assemblies, or we can ship you a skid like this bottom picture shows. And in this case, there's 3 pumps on here with 3 VFDs, all the associated piping specialties and everything on there, and you can bring that skid right into your mechanical room. Or we can ship you an entire building with a roof and walls and everything if you want. So we can help you out with that custom stuff for larger projects. We do handle Bradford White water heaters. Really hasn't anything to do with the boilers other than they pipe the same way. And there's nothing sexy about a water heater, I won't lie to you guys. But there is one cool thing that has happened recently, and that's the icon controls that are available for these guys. As you can see here, some of the accessories that are available now with this new icon gas valve that Honeywell makes for them is a setback thermostat. You probably have never had a setback thermostat on your water heater before. Now you can do that. It's a pretty cool feature. The other cool feature is a leak detection sensor. You put this down on the floor by the water heater, and you can either put this rubber dam around it to make a little loop, or if you're putting the water heater in a tray, even better. If it senses any water on the floor by the water heater, it shuts off the gas valve. It sounds the buzzer on the control module here up on the side, and then if you were smart enough to put in the shutoff valve for the inlet water, it'll also shut off that valve so I won't bring any more city water in there. So if you go on vacation for the week or whatever, you don't have to worry about your water heater leaking into your basement, along with 40,000 gallons of water from the city pumping its way in. And to be honest, when people replace a water heater, it's because it leaked, right? So it's not because they just wanted to replace it. It's because there was a leak and they probably already had water damage. Now you can help them avoid that in the future. But from the energy perspective, you got a setback thermostat in there now. On our hydronic side, we also handle some geothermal heat pumps. Obviously, we have air side heat pumps, but we do use water-to-water heat pumps as well. So we can take that groundwater and use it to feed into a radiant floor for heating. And on the really large size, we have custom solutions through EnviroSep, and they might build us custom pumping stations like you see here, or maybe they'll build us an entire penthouse building with boilers already in it, and you can just ship it to the job site and drop it down. All kinds of cool stuff like that. There's pretty much nothing they can't do regarding piping and hot and chilled water. And we have all the applicable accessories that go with these things. We got chemical treatment tanks, expansion tanks, VFDs, valves, cast iron radiators. We have fin tube radiation through Excelsior, our sister company. We got wood-fired boilers for anybody who needs a wood-fired boiler. So if you're out in the rural area and you got plenty of wood available to you and a 17-year-old son to chop it off for you, great. We'll get you a wood-fired boiler. And we have all the applicable controls and accessories that you'd expect to have with a boiler. Control valves, stats, pumps, all that kind of stuff. That's our complete line card, and it grows and changes pretty much every month, I think. There's always something new being added to it. And there's stuff that we have that we don't even have on here, like heat exchangers and things like that that you might use on a hydronic system. All right, let me check if there's any more questions here, and then if not, I'm going to tell you about one more financial related thing here. Let me blow this up so I can see this question a little better here. It's a long one. Let's see. Is there something special to be done for well water on a boiler, i.e. chemical or other procedures? The answer to that question, like every question, is probably maybe, but in reality it's probably no. A boiler is, for all practical purposes, a closed system. So unlike a water heater, you're not constantly grabbing new well water and bringing it into your hydronic boiler system. Right? The boiler's closed loop. The boiler is pumping the exact same water around in a big circle between the coils, the expansion tank, the pump, boiler, and back around the whole circle again. Now, if you have a leak and you're losing water, that's when you'd be introducing new makeup water from the well system. So hopefully you don't have a leak and hopefully it's not an issue. So you're not, once it's filled up and all the air is taken out of the system, you shouldn't really be bringing any more water into that system. So I would say no, you don't have to do anything special in that regard. That, anything you're doing for your domestic water now is fine. There's a question here. If they do multiple loads, is it one at a time? I think John in that question was referring to when I mentioned some of these boilers can handle 2 or 3 different varying loads. And the answer to that question is yes, it would be one at a time. So you would stop sending water to your radiant floor system, for example, and send it over to your domestic hot water tank for 10 minutes while people took a shower or whatever the case may be. And then when the domestic tank is back up to set point, you go back and do the floor. And for those of you that have radiant heating in your homes, you know very well you could turn off the water for 2, 3, 4 hours and that floor would still be warm and you wouldn't even notice it, right? Once you get up to temperature for the season, it's pretty much warm and you're just keeping it warm with the boiler. So now if you have something else like thin copper fin tube radiators, now maybe you might want to think twice about pulling away from that to go handle other loads. But for radiant floors or for cast iron radiators, something with some mass to it, you can certainly do it. The next question here is I've heard that in older hot water heating systems that the old style fin tube radiators do not throw off any heat if the water temperature is below 130 degrees, and so the condensing boilers cannot get to their condensing temps. Is that accurate? And if so, are there other types of boilers to use? That is somewhat accurate. Fin tube radiators don't do well with low temp water, and low temp would be under 130 degrees, and that's where condensing boilers like to live. Radiant floors do very well because you can't even have them above 130 degrees at any time of year, so they do very well. The more surface area you have to work with, like a radiant floor, the lower the temperature can be. It's not that you won't get any heat out of a fin tube radiator with 130 degrees. It's just that you don't have a lot of surface area to work with, so you're not going to get a lot of heat out of it. So really is not as advantageous. Sure, when it's 60 degrees outside, 130 is probably fine, but you're going to need to get 180 real quick as the temperature starts dropping outside. So there's not as much benefit to it. Now those boilers, if you put a 90% condensing boiler in there, he's not going to be in the condensing mode very much on a fin tube job. But he's still more efficient than the old 65% or whatever you took out of there, right? So I don't know exactly, but let's just say, for example, instead of being 95% efficient, if you keep him up at higher temperatures, like if you keep him running 170, 180, maybe he's only 87% efficient. Okay, fine. It's better than the 65 or you took out, but it's not as good as if you had a heat exchanger with a lot of mass, like a radiant floor, or even some of the heat exchangers you have in an air handler. I got a question from somebody to tell them more about the icon system, so I'll do that. I'll do that offline with him. And then what I'm going to do right now is jump back over into this presentation and finish up the last few things here. So what I have on the screen here, and I'm sure some of you have already read it by now, is Cook County's Energy Efficiency Community Block Grant. What the heck does that mean? As part of the federal stimulus money, the states and individual municipalities got some of that money to use for energy efficiency upgrades. And large communities like the city of Chicago took that money directly and decided how they would use it, and they used theirs for streetlights or whatever they decided to do with it. Some of the smaller communities under a certain size, and I want to say it's under 35,000 people, were not allowed to take it directly. They had to pool their money together into a program. And in this particular case, Cook County has done that. So this is for suburban Cook County, meaning Cook County but not Chicago. You can get right now free energy audits for commercial buildings. They're going to do about 150 buildings. If you've never had an energy audit done, a typical average energy reductions after an energy audit, assuming you actually implement the recommendations, is about 30%. Sure, some buildings might be 10 or 15%, other buildings might be 70%, depending on how bad you were running it. But on average, it's probably about 30%. And I didn't pull that stat out of my rear. I actually got that from somebody who's in the know. But I could have pulled it out. You still would have believed me, I'm sure. So free energy audits. The organization that's doing it is the Delta Institute. So they've been hired by Cook County to run this program. It's delta-institute.org/Cook Efficiency. They have multiple auditors that they're working with, one of which is AKT Peerless, who we have a good working relationship with here at TEC. So we're obviously promoting and suggesting that folks take advantage of that. This is the kind of stuff that's going to be included in that energy audit, and depending on the type of building, it'll determine the complexity of the audit. But there'll be a walkthrough of the facility. They'll review all the findings with the owner. They'll coordinate with the facility management people at the building so everybody's on the same page. And they're also going to implement or help them implement some of the funding sources available. This program itself has some funding associated with it, and then there's additional funding that they'll help you identify and implement. So they'll help you out with claiming your utility rebate incentives. They'll help you out with the applications that they have for their revolving loan program that's part of this whole auditing program. So they'll help you get the financing to actually make the project happen. So what happens with a lot of times, if you talk to any of these energy auditors, they go in, they get paid to do an audit, they give you a nice thick report with all the things you should look at doing, and then it gets filed away in somebody's desk drawer somewhere because nobody wants to spend the money to do it. So the goal here is not only to give you the energy audit and tell you what to do to improve your building, but to help you fund it and make that all happen financially. That's the way this is supposed to go down here. So these are available free to building owners. Not-for-profits are excluded, and municipal buildings like schools and stuff are excluded. But any other commercial facility would be welcome. They are targeting small and mid-sized buildings, but there's nothing that says you can't submit an application for a 1 million square foot building if you wanted to. Here's a map showing you which counties are eligible. Which cities are eligible. If you're in a city that straddles the county, then you may or may not be eligible, depending on what side of the border you're on. And obviously the city of Chicago is not included, nor are any other large communities that took their money directly. So there's a list physically of all of the cities. And if you go to that website, delta-institute.org/Cook Efficiency, you'll get this list and you'll have it of all the towns that are available. So if you're working with a property owner or management firm and you've quoted them some boiler replacements and you're trying to get them some high efficiency stuff and they're just not getting it done, they don't have the money, whatever, this may be one way to help move that along. You can get a free audit for them so they can identify more things they can do in the building and then help them get those loaning resources that they need, or in some cases grant monies, to make that happen. And additionally, at TEC, we also have our own program. We don't do loans, but we do equipment leasing. And buildings, they lease a lot of stuff, software, copy machines, and all that stuff, but most people don't lease HVAC. We can do that on commercial stuff. We can lease you a boiler or a rooftop air chiller or anything else you want. We can lease you, as long as it's a $3,000 project or more, and as long as it's a commercial building, we can lease that to you. And the way we like to do it is the leases can be structured from anywhere from 2 to 5 years. And what we like to do is set it up so that the energy savings you're getting off of your boiler is pretty much going to pay your monthly lease for the most part. And then when the lease is paid up, there's a $1 buyout at the end, because obviously we don't want the boiler back, nor does our partner Urban Leasing. So the building owner keeps the boilers that we put in, and they pay $1 to buy it out at the end, and then the monthly energy savings starts going in their pocket. So instead of paying their lease, the energy savings goes in their pocket. It's a good deal all around. So I mean, you got to have decent credit. You can't be a total deadbeat. You got to have decent credit. But if you have good credit and you don't have bags of money sitting around, bags of capital, this might be a way to get a project done. Then at our facility, we do a lot of different things, as most of you know. We do training. We do, like I said, webinars every single Monday. And I'll pull up the webinar schedule here for you in a second so you can see what the next topic is. We do have a hands-on, pardon the picture of my kids. We do have a hands-on training lab in Melrose Park. So we do classes there where we teach people how to clean boilers, how to program boilers, how to pipe boilers, all that kind of stuff. The next webinar is going to be on November 22nd on energy recovery ventilators, and Stacy will be doing that topic. Okay, so that's next time. We record a lot of these webinars, so if you go to our website, tecmungo.com/training, you'll be able to then either click on a list of classroom training that's coming up, or click on webinars, and the webinars will show you the webinars that are coming up, as well as the ones we've already recorded, and you'll be able to link to them from there. In addition to our hands-on lab where we have full hydronic systems as well as airside systems, we also have our mobile solutions truck, which we physically can drive out to your facility, bring equipment in there, and physically show you and your technicians or your customer or whoever what needs to happen with some of that equipment. We do have access to a free hydronic system software tool that you're welcome to have. You can get it from the website down at the bottom there, multiaqua.com. That's one of our chiller suppliers. However, this software is made by a company called HVAC Solution, which is a little different than my company, No S, HVAC Solution. It's normally software that you would buy, but through Multi-Aqua and through Taco Pumps, they are giving us the hydronic portion of it for free. If you want airside and ductwork and air handlers and all that, you'd have to upgrade it. But for the hydronic side, it is available for free. It's pretty cool too, because you can do professional-looking drawings, lay out all the coils or the radiant floor, or the swimming pool, or whatever it is you're trying to heat, show the boiler, show the piping. The software not only will make it all look good for you and show you all the various loads on there, but it'll also size the pumps for you and size the piping for you. So it'll tell you, oh, you need 2-inch pipe on this segment in order to make that flow happen, etc. Like any other software, garbage in, garbage out, so you still got to know what you're doing, but at least it kind of beats doing everything by hand, if you will. And we have tons of software tools that are related to hydronic systems. Like I said, we got the hydronic design software, we have geothermal software, we have pump selection software available through Grundfos, we have water heater sizing software, all kinds of good stuff like that. So with that, I think I hopefully have saturated you enough with gas rebates, boiler product lines, and some of these other things that are going on that you got a good idea for what's happening. Let me see if we have any additional questions here that I can help answer. If you use the boiler for domestic hot water, is there a setback at night so the domestic hot water tank can drop temp on that rotating use model? There's not inherently. You'd be setting one temperature up in that tank. You could add additional controls to make that happen if you wanted to. But out of the box, all those boilers I showed you that automatically switch between domestic hot water and the space loads, typically are just trying to maintain a specific temperature in that tank. But it could be modified with additional field controls to make that happen. I don't know that the cost of the controls would justify the minimal amount of energy savings you'd have on a well-insulated tank. So when I was talking about the water heaters from Bradford, I was promoting the fact that you had that setback thermostat that's available on them. And that's because there's quite a bit of energy loss on a water heater. You got a lot of heat that's going up that flue on the water heater. With a indirect storage tank, these things are pretty well insulated. You're not losing a lot of heat on the tank itself. So once you get the tank up to 160 degrees, you're pretty much there, and you're losing like 1 degree an hour. So if you turned it off at 10 p.m. and turned it back on at 5 a.m., I mean, instead of being 160, it'd be like 150. It wouldn't be a big savings because I don't have a giant flue pipe running up the middle of that thing, right? So there's not a lot of potential for savings there. Although it would be nice if you could tweak it a little bit just to save that little tiny bit. But the controls required probably wouldn't pay themselves back. Another question, actually it's a comment from John Mansfield at Resource Solutions Group, who's one of the folks that administers the gas utility rebates for NICOR Peoples in North Shore. he wanted to comment that there's actually a training class available for that Cook County Energy Audit Program. That's tomorrow, which is, what is tomorrow? The 16th, I think. But tomorrow there's one session, and then on November 23rd there's a second session if you miss it tomorrow. If you go to NICORgasrebates.com and you navigate yourself over to the training page, you'll see that NICOR is hosting a class on behalf of that Cook County Efficiency Energy Audit Program. So that's a good point, John. Thank you for mentioning that. If there's any other questions, please do type them in the question chat box, and I'll try to answer them. Or you're welcome to contact me later. My phone number is 708-670-6383, or my email, ryan.hoger, H-O-G-E-R, at hvacsolutions.com. And with that, I thank you all for coming. If you need access to the recorded version of this webinar, let me know. I'll have it posted up sometime later this afternoon. Thank you very much for coming in. Bye.